how do we really know that that angle sum formula is true? What happens if I just rotate a single point? For instance, if I take this point here, point 1, 0, and I rotate it through an angle of theta, then I end up at the point cosine theta sine theta. Somewhat similarly, if I take this point here, the point 0, 1, and I rotate counterclockwise through an angle of theta, I end up at the point minus sine theta cosine theta. What if I rotate some other point, x comma 0? Well, if I rotate x0, say x is some number between 0 and 1, well, then I just think about where does 1, 0 go, right? 1, 0 rotated to cosine theta sine theta, so x0 must rotate to x cosine theta, x sine theta, a point on the middle of this red line. What if I rotate 0 comma y through an angle of theta? Similarly, if I've got some point 0y, say y is between 0 and 1, some point on this red line, if I rotate that point through an angle theta, well, the point 0, 1 rotates over to the point minus sine theta cosine theta on the circle, so the point 0y rotates to a point on the red line with coordinates minus y sine theta, y cosine theta. All right, it's exactly this point, but scaled by y. Okay, so we know how to rotate x comma 0, and we know how to rotate 0 comma y. How do I rotate x comma y? So what if I rotate this point, x comma y, through an angle theta? Well, let's rotate this, and all I really have to figure out is where does the point x comma 0 end up, and where does the point 0 comma y end up? Well, x comma 0 ends up at x cosine theta comma x sine theta. This point started off as x comma 0, and when I rotate that through an angle theta, this is where it ends up. And this point started off as 0 comma y, and if I rotate that point through an angle of theta, this point ends up at minus y sine theta, y cosine theta. Now where does this point x comma y end up? All I have to do is just add together these two coordinates to figure out the coordinates of this other point. And that means that this point x comma y ends up at x cosine theta minus y sine theta, and its y coordinate is x sine theta plus y cosine theta. So now I know how to rotate a point. How does that help? The goal was to try to justify the angle sum formula. The trick is to think about what happens when you do successive rotations. If you first rotate through an angle alpha and then an angle beta, that's the same as rotating through an angle alpha plus beta all at once. Specifically, if I start with the point 1, 0 and rotate through an angle of alpha, it ends up at cosine alpha sine alpha. I could then take that point and rotate it through the angle beta, and I've got a formula for that. Once I do that, the new coordinates are cosine alpha cosine beta minus sine alpha sine beta, and the new y coordinate is cosine alpha sine beta plus sine alpha cosine beta. But that's the same point as I'd get if I started with 1, 0 and just rotated the whole thing initially through the angle alpha plus beta. This means that cosine alpha plus beta must be equal to cosine alpha cosine beta minus sine alpha sine beta, and sine alpha plus beta must be cosine alpha sine beta plus sine alpha cosine beta. These angle sum formulas can look very mysterious when they're written down, but they're really coming from a very simple source. They're coming from the fact that rotating through one angle and another angle is the same as rotating through the sum of those two angles.